doing some conversion factors. It's also called dimensional analysis or factor label, but this is a way to convert between metric and English for sure. You can also do it to go from metric to metric if you don't like moving the decimal, but I'm going to show you how to do it from metric to English today. And so a conversion factor is just a way to change the units. You're not changing the overall value of whatever. So if we were going to measure this notebook, the length of it in inches, but then if I want to know what that is in centimeters, I can use conversions to convert to that. I'm not changing the length of this. It's just going to be, I'm going to have the value in centimeters in different units versus inches. So a conversion factor doesn't change the overall value of the thing, but it does change it to different units. So it'll have a different number with the units, but it's equivalent to what it is in a different unit. So a conversion factor is simply a relationship between two objects that are equal. For instance, 1 inch is exactly equal to 2.54 centimeters. Or I can flip it and I can have 1 inch on top and 2.54 centimeters on the bottom. That's an equivalency. That's can be used as a conversion factor. So if I'm in inches, I could use this to get to centimeters. If I'm in centimeters, I could use this to get to inches. A conversion factor is equal to 1 because what's on top has to be equal to what's on bottom. You can't just make something up. So while it's true that 1 foot is 12 inches or 12 inches is 1 foot, it is not true that 12 feet are 1 inch. That's not true. So I can't use that as a conversion factor if it's not true. You can't just make up what you want to put on here. Okay, I can't change this amount. It's always 12 inches is 1 foot. Okay, so I am giving you a conversion table that you're allowed to use on quizzes and tests when we're doing conversion factors. You won't be allowed to use it on the metric quiz, which is just metric to metric, because you have to memorize all those metric prefixes and that. But for the conversions, you can use this table. If you can print off a copy, that'd be great. If in class I give you a copy of it. And it has a lot of different things on there, like different conversions of volume, and they're just equivalencies. So it's true that 1 quart is 0.95 liters. Okay, that's a conversion between English and metric in volume. It's true that 4 quarts is a gallon, that 1 cup is 8 fluid ounces. So all of these are true facts. All of these can be used as a conversion factor. You should know one way for volume, mass, and distance to convert between English and metric. Okay, and so for volume, the one on here is quarts to liters. 1 quart is just about a liter, 0.95. Okay, for mass, we have either 1 pound is 453.6 grams to cross over from English to metric, or we have 1 kilogram is 2.2 pounds to cross over from metric to English. Either one of those is fine to use. I can easily remember that 1 kilogram is about 2.2 pounds. So if I travel and I know my weight in pounds and someone wants to know it in kilograms, I know I can just divide by 2.2. Also, if I'm traveling and I see the price of gas, it's probably given in liters, whereas we in America do it per gallon. And this would help me realize. So a quart is about a liter. So a liter is what they do it, for instance, in Canada, how much it is per liter. So then I have to multiply that by 4 to figure out what it is per gallon. So sometimes the liter sign doesn't look too bad. Then you multiply by 4 and you're like, wow, that is really expensive gas. Okay, so quart is about a liter. 0.95 is the conversion. And for distance, one of the most common is that an inch is 2.54 is a conversion, or 1 mile is 1.609 kilometers. Okay, so using these conversions, we're going to do some problems. Let's skip over to this one. Okay, so for this one, 12.5 feet, I want to convert that into meters. So whatever I start with, I'm going to make sure I label everything. And I like to put the initial thing over 1. You don't have to. And I like to use parentheses. Now, some people use like straight lines like this. That's fine. You could have 12.5 feet here over 1. Same difference. The key is whatever unit I start in, that unit has to be on the bottom in my conversion factor. So if I am starting in feet, feet is here. I don't bring the number with it. I need an equivalency here. So I know that 1 foot is 12 inches. That's not on the paper. You're expected to know that. Okay, same thing down here. I can say 1 foot is 12 inches. Okay, so now feet on the bottom cancels feet on top. Right now, if I stopped and did 12.5 times 12, I would be in inches, but I don't want inches. I need to get over to meters. So now I have inch on top. I put inch on the bottom, always. Whatever unit's up there, make sure you're writing that unit. Now I need an equivalency. Knowing that I want to get to meters, I'm going to use this. That inch is 2.54 centimeters. So 1 inch is 2.54 centimeters. Again, this has to be equal to each other in this conversion factor. 1 inch is 2.54 centimeters. It doesn't matter that I had this many inches or whatever. In here, I'm just writing equivalency. At the end, I'll do my multiplying and dividing. But right now, this is telling me that this is equal, and I'm going to convert from inches to centimeters. So inches cancel. I'm in centimeters. I need to get to meters. So again, centimeter has to go on the bottom, and I have a conversion from centimeters to meters. There's 100 centimeters in 1 meter, and my centimeters cancel. So now I've ended with meter on top. That's an M. And I just need to do my multiplying and dividing. So if I were continuing down here, it'd be the same. Inches were on top, so 1 inch is 2.54 centimeters, and 100 centimeters is a meter. Okay, same difference, whether I do it with straight lines or parentheses. Math-wise, any number on top, I multiply by. Any number on bottom, I divide by. So in my calculator, I'm going to see I have 12.5 on top. So it's 12.5 times 12 times 2.54. Those are all on top. They're all times each other. And then on the bottom, I have 100. So I'm going to divide by 100. So I personally always zigzag my way through. Any number on top, I multiply by. Any number on bottom, I divide by. Alternately, you could multiply all across the top, multiply all the ones across the bottom, and then divide. You'll get the same answer. I just find it faster to just zigzag through rather than do that, stop, do that, and then divide. But either works. Okay, so when I do that, when I do 12.5 times 12 times 2.54 divided by 100, I get 3.81 meters as my answer. Okay. So you might think, oh, that's a lot of writing. I can do it faster, whatever. I would really like you to try it this way, because this is the pattern that we're going to use for lots of other types of conversions all year. So I really would like you to try it this way, writing down all the units, doing conversion factors, then multiplying and dividing at the end to get it set up like this. So for the next couple of days, I want you to try all the problems like this and write it out. Okay. And this is really useful. I've had people tell me all the time that they use this in physics. They go on to college and use this. So conversion factors, following the units is so helpful. You can even use it in math story problems. So like this problem, you're throwing a pizza party for 15 friends and figure out each person might eat 4 slices. How many pizzas will you need? And then how much will you have to spend on pizza? Side note, an extra large pizza has 12 slices and costs $13.50. So with this, just from reading those, I can see some equivalencies. So here's one here. One person or friend, I could change that to friend. One friend is going to eat 4 slices, or each friend is going to eat 4 slices. So that's a equivalency. That's a conversion. So one friend eats 4 slices. What else do I have? An extra large pizza has 12 slices. So that is a conversion. An extra large pizza has 12 slices. And also, an extra large pizza costs $13.50 is another equivalency or conversion. So when I start, I have 15 friends. And then friend has to go on the bottom. And my conversion is that for one friend, I need 4 slices of pizza. Friends cancel. Now I'm in slices. So then I have a conversion of slices to pizza. Slices is on top. So slices has to go on the bottom in this one. So 12 slices is one extra large pizza. So now 15 times 4 on top divided by 12 on the bottom, I come up with 60 divided by 12, 5. So I need 5 extra large pizzas to answer part A. Then part B asks about cost. So for 5 XL pizzas, one XL pizza is $13.50. Gets me from pizza to dollars. And so that is 5 times $13.50. And I'm going to need to spend $67.50 for my party. Okay, so this is just an example that these conversion factors, this idea, can be used to solve story problems. It can be used to solve lots of different types of physics and chemistry problems. Okay, so the paper that I have for you, if you're doing this just online, you should be able to print out this paper on conversion factors for the first problems that we're going to try. So this first problem, you can punt a football 32 yards. How many meters is that? So 32 yards is what I'm starting in. And I want to get 2 meters. So yards is on top. I have to put yard on the bottom. So what do I know? Well, I know that 1 yard is 3 feet. Okay, so I'm going to go to feet. I need to get to meters. So as I look over that list of conversions, there's actually 2 different ways I could go. I can go now from feet to miles and miles to kilometers and then kilometers to meters. Or like that other one, I could go from feet to inches, inches to centimeters, and then centimeters to meters. And either way is fine. A lot of times there's more than one pathway. If you're following your units, then there's different ways to do it, and they'll all give you the same answer. Okay, so yards cancel. So I'm in feet. So I'm going to go ahead and go to inches. So 1 foot is 12 inches is a conversion. That gets me to inches. Now inches is on top. So I want to put inch on the bottom. And I want to go to centimeters. Inch cancels. I'm in centimeters. I need meters. Centimeters is on top. So here, centimeters has to go on the bottom. And there's 100 centimeters in a meter. So now, once again, all the numbers on top multiply by, any numbers on the bottom divide. There happens to be a lot of ones on the bottom. That doesn't always happen. It doesn't matter what the numbers are. They're not always going to be ones, but you divide by them if they're on the bottom. So this will be 32 times 3 times 12 times 2.54. and then that 100 is on the bottom, so then it'll be divided by 100. Okay, so that one is going to be 32 times 3 times 12 times 2.54 divided by 100 comes out to be 29.26. I'm going to round that to 29.3. And my units are meters. Whatever you end up with on top, those canceled, is your overall answer when that's what it asks for. It asks you for meters, and we ended in meters. Okay, so you need to try the other ones on that paper as best you can. Try to set them up this way so that you're following the units and doing your multiplying and dividing at the end. Okay, so just try this and we'll see how you do with it.